Welcome to the Diagnostic Clinic. I am absolutely thrilled to have you here today. I'm your host, your lead strategist, and today we are stepping into the role of the lead physician for your Cambridge physics exam preparation. We are going to diagnose the exact symptoms of a failing answer, and more importantly, I am going to prescribe the exact cure to get you those top marks. So let's dive right into this. Did you know that mastering the electromagnetic spectrum, specifically the main regions, their frequencies, wavelengths, speeds, uses, and harmful effects, accounts for approximately 15% of the total marks in your Cambridge physics examination? Whether you are sitting for syllabus 0625, 0651, 0652, 5054, or even AS level 9702, this topic is an absolute gold mine. But so many students leave these marks on the table. Consider two typical students taking this exact exam. We'll call them Alex and Sam. When Alex sees an EM spectrum question, he panics and just overloads the answer page with raw, disconnected physics facts, offering absolutely zero contextual analysis. Sam, on the other hand, rushes through the paper, completely missing the specific command word requirements like state, describe, or explain. If we were to put their exam papers side by side right now, we would just see a sea of red pen marks from the examiners. Today, our mission is to transform those red marks into green check marks. We are going to build your mark potential from 0 to 100%.
Here is our Diagnostic Clinic blueprint for today's session. We'll start with the EM spectrum baseline, then move on to building cross-topic connections. Next, we'll unpack a real game changer, the method mark strategy, followed by mastering comparative analysis, and finally, we'll conclude with the top examiner warnings.
All right, Section 1, the EM spectrum baseline. Before we can even begin to apply complex exam strategies, we absolutely must establish the foundational anatomy of our subject. Okay, look closely at this absolute constant right here. 3.0 times 10 to the power of 8 meters per second. This is the constant universal speed at which all electromagnetic waves travel through a vacuum. Listen to me carefully, because this is where students like Alex mess up. Whether it is a massive radio wave stretching for kilometers across the sky or a microscopic, highly energetic gamma ray, in a vacuum, they are all moving at the exact same speed. Examiners absolutely love to test this because it's a foundational constraint of the entire universe. When you see a Cambridge question asking you to compare the speed of microwaves versus X-rays in the vacuum of space, your immediate reflex must be this exact constant. Burn this number into your memory right now, because it is the ultimate anchor for so many calculation and comparison questions. When Sam rushes through a question and sees the command word calculate, he starts looking for complex formulas, entirely forgetting that if it's an EM wave in a vacuum, the speed is already given to him by the universe. This constant is your baseline.
Now, because all EM waves share that constant speed we just talked about, frequency and wavelength must act like a seesaw. It's an inverse relationship. As you move across the main regions of the spectrum, if frequency increases, meaning more individual waves pass a given point every single second, then the wavelength absolutely must decrease to compensate. Conversely, increasing the wavelength means decreasing the frequency. When an exam question asks you to arrange the regions, say infrared, ultraviolet, and visible light, in order of increasing wavelength, you must apply this inverse logic flawlessly. It's not just about memorizing a static list. It's about fundamentally understanding the mechanical relationship between these properties. And this is where we introduce the Peel framework. Point, evidence, explanation, link. Top students structure their answers using Peel. If the question asks why X-rays have shorter wavelengths than microwaves, your point is that they have a higher frequency. Your evidence is their position on the spectrum. Your explanation is this exact inverse relationship tied to the constant speed of light. And your link ties it back to the specific context of the question. Let's do a quick 30-second mental timer here. Think about how you would structure that Peel paragraph right now. Spotting this relationship is what gets you the marks.
The crucial baseline data you need is summarized right here in this table. You need to know the main regions, their typical uses, and their harmful effects inside and out. For example, radio waves are used for broadcasting and television. Microwaves are essential for satellite communications and mobile phones. X-rays are critical for medical imaging, and gamma rays are used for sterilizing medical equipment and treating cancer. You also need to know the harms, right? Like ultraviolet radiation causing skin cancer or cataracts, or gamma rays penetrating deep tissue and mutating cells. But listen closely to what I'm about to say. Memorizing this table will get you a passing grade, maybe a C, but it will not get you an A star. Top marks require actively applying this data to completely unfamiliar context, not just reciting it like a robot. Alex memorizes this table perfectly, but when asked why microwaves are chosen over radio waves for satellite links, he freezes. He has the raw facts but no analysis. We need to go deeper.
Moving right along to Section 2, building cross-topic connections.
This is exactly how you elevate your game from an average student to a top-tier candidate demonstrating fully transferable conceptual understanding.
To do this successfully, you need to build your theoretical architecture on 3 vital pillars: precise definitions, causal relationships, and integration with other syllabus areas. You can't just define a term and drop the pen. You must explain why it matters. For instance, you don't just state that gamma rays are a high frequency. You establish the causal relationship. Link that high frequency to their incredibly high energy levels. And then, here is the magic part, the integration. You connect that high energy to radioactive decay from the nuclear physics chapter. Integrating topics like this demonstrates true master-level fluency in physics. It shows you understand the whole shebang, not just isolated chapters. Now, before we continue on to the Examiner's Insider Tips, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. It is the best way to ensure you are getting these high-level strategies every single week.
And hey, you don't just have to take my word for it. Look at this direct quote pulled straight from the Cambridge Principal Examiner reports. Candidates referencing cross-topic connections achieve significantly higher marks. The examiners are literally handing you the cheat code right here. When a senior examiner is sitting at a desk grading hundreds of papers and they read an answer that successfully links the thermal heating effect of infrared radiation to the kinetic theory of particles from the thermal physics unit, their eyes just light up. They are actively searching for candidates who can weave different strands of the syllabus together into a cohesive argument. It proves beyond a shadow of a doubt that you aren't just memorizing flashcards the night before. You are actually thinking, reasoning, and analyzing exactly like a physicist.
Right, let's pivot to Section 3, the method mark strategy. This is an absolute game changer. Marks are awarded for the procedural framework itself, even if you mess up the final calculation.
Let's walk through the exact procedural checklist examiners look for when grading your data interpretation skills. This is how you secure those critical method marks. Imagine a 60-second timer on your screen right now as we do a live rewrite of a bad answer. Step 1. Extract from texts or tables. When you are given a complex scenario or a dense data table, literally pull the specific data points out and write them down on your paper. Show the examiner you found the needle in the haystack. Step 2. Interpret the relationships. If the table shows frequency increasing, explicitly state the causal relationship to wavelength or energy. Don't leave it in your head. Step 3. Draw evidence-based conclusions. This is where we bring back the Peel framework: point, evidence, explanation, link. Make your point, back it up with the specific data you extracted in Step 1, explain the underlying physics principle, and explicitly link it back to the command word in the question. Watch as Alex and Sam use this exact 3-step procedure to transform their vague, rambling paragraphs into tight, focused, high-scoring answers. Those red marks are turning to green check marks right before our eyes. This framework is your ultimate safety net during the stress of an exam.
And remember, the presentation of your information follows strict conventions. Notice these expectations on screen. You must use proper headings, appropriate formats, clear annotation, and absolutely correct scientific terminology. Don't ever write "light gets bent." That's what a middle schooler writes. You need to say "the wave refracts." Sloppy, casual work directly penalizes your practical application marks. Examiners expect a professional presentation, and they will absolutely withhold marks if your fundamental formatting is ignored, even if your underlying physics is technically correct. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Welcome to Section 4, Mastering Comparative Analysis. We are now entering the higher order territory, where you are evaluated on your ability to compare alternatives and provide strongly justified recommendations.
Let's compare an average candidate and an expert candidate in real time. We are going to do a quick interactive workshop right here. Challenge 1 is the data scan. Imagine a complex graph on screen comparing different wave penetrations. You have 60 seconds to extract the chord trend. Got it? Good. Now, challenge 2, find the flaw. A typical candidate, like Alex, looks at radio waves and microwaves and writes this exact sentence. They are both electromagnetic waves and they both travel at the same speed. Take a few seconds to spot the flaw in that paragraph. Did you find it? The flaw is that it's just a baseline answer. It only states similarities. It's not factually wrong, but it's wildly incomplete. A top-scoring A-star candidate identifies both similarities and differences. They will write, while both are electromagnetic waves traveling at 3.0 times 10 to the 8 meters per second in a vacuum, microwaves have a significantly higher frequency and shorter wavelength than radio waves, making them more suitable for satellite communication because they can effectively penetrate the Earth's ionosphere without significant diffraction. Wow! See the massive difference in quality? That is critical analysis in action.
To guarantee you hit that top-tier level every single time, here is the specific evaluative framework you need to memorize. First, always identify both similarities and differences. Never just look at one side of the coin. Second, use comparative connectives. Words like whereas, conversely, however, or in contrast act as massive flashing signposts to the examiner that you are actively engaging in comparison. Third, support every single comparison with specific evidence extracted from the physics syllabus or the data provided. And fourth, conclude the relative importance based entirely on the context of the question asked. Time for challenge 3, speed writing. I want you to imagine a 30-second timer counting down right now. Could you write one perfect Peel paragraph using these 4 steps? If you practice applying this exact framework, you will completely justify your decisions and secure the absolute maximum marks available for any comparative question Cambridge throws at you.
Finally, we reach Section 5, Top Examiner Warnings. We've talked extensively about the theoretical architecture and the writing methodologies. Now, let's diagnose the most common symptoms of a failing answer straight from the chief examiner's desk.
So I want to pose a direct, serious question to you right now. Think about everything we've unpacked in this clinic today. Where do you honestly think most students actually lose their marks when tested on the electromagnetic spectrum? Is it the complex math? Is it forgetting the exact order of the waves? Surprisingly, no. The biggest pitfalls highlighted year after year in the principal examiner reports are much more fundamental to how students actually structure their thoughts on the exam paper. Let's reveal the top 3 symptoms of a weak exam paper so you can avoid them entirely.
Here they are. Symptom number 1. Answers are way too vague. Students write lazy things like, "it causes harm," instead of "ultraviolet radiation causes intense damage to surface cells and eyes, potentially leading to skin cancer or cataracts." Examiners are actively instructed to penalize vague generic details. You must be specific. Symptom number 2. Format and presentation are completely ignored. Skipping units, drawing messy, freehand diagrams instead of using a ruler, and using non-scientific vocabulary will bleed your marks dry. And symptom number 3, which is perhaps the most fatal error of all, answers are not specific to the given context. If the exam question is about a specific medical application of X-rays in a hospital, and you just recite a memorized paragraph about X-rays being used in airport security luggage scanners, you will score a 0. It shows you aren't reading the paper. This ties directly into our 3 rules that guarantee top marks. Number 1, command word decoding. Know what explain versus state means. Number 2, strict Peel framework application. And number 3, a time management matrix so you don't rush like Sam.
I want to drive home this ultimate examiner alert with one final, incredibly important quote. The classic mistake is providing generic answers. Always link every point to the given scenario. Rote memorization entirely fails if you do not anchor your answer to the specific context of the question sitting right in front of you. Students who implement these physics strategies see an average improvement of 2 whole grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by without having the best strategies in your toolkit. Drop a comment below with your exact target grade for physics and the biggest challenge you're currently facing. Our team reads and responds to every single comment. Make sure to like and share this video with your study partners so you can hold each other accountable. Ace the Exams. Your Cambridge success starts here. As we officially close the doors on today's diagnostic clinic, I leave you with this final, vital question. How will you approach your very next past paper? Are you going to be like Alex and Sam, blindly memorizing disconnected facts and rushing through command words? Or are you going to build the architecture, apply the method marks, use the Peel framework, and master contextual analysis? The tools for an A-star are laid out right in front of you. The progress bar to your maximum mark potential is in your hands. The only question left is whether you are ready to stop memorizing and start thinking like a true physicist. Good luck with your revision, and I will see you in the next session.